This is an infinite cobblestone generator in Minecraft, and this is one I just built out of LEGO parts. And it actually works thanks to some really cool underground mechanisms that are like real life redstone. Wow. This machine has so many awesome features, and I'll show you all of them. Most importantly, I needed water and lava. When they mix, a new cobblestone is created. Then a piston will push the new cobblestone out of the way so more cobblestone can be formed. At the end of the line of cobblestone, I wanted to make it look like Steve is mining it with a diamond pickaxe. There would be a floor to support all the cobblestone except the final one, but the piston will apply enough pressure to hold this final cobblestone in place until Steve mines it. When the piston releases pressure, the cobblestone will fall onto a conveyor to get on this lift and be recycled back to the water and lava so the process can be endless. First I had to set the scale. Minecraft blocks are cubes, so I built most of my items as cubes too. With LEGO parts, this can be achieved by adding a plate and tile to a brick, or connecting 4 plates on one tile. I mostly used the 4 plates method and scaled this concept up to a 4-stud cube to get a lot of detail in a small package. The cobblestone build came first, which turned out really nicely. After that, I designed the piston rod. Next, I built the piston housing. The ram didn't move freely in this housing though, so I designed another housing with one open wall. I wasn't sure which of these designs would end up being better, so I kept both around just in case. After the piston, I created the water. The water and lava are both a little bland, so I'll make them more interesting later. This is already starting to look like the game, but there's more to be done. Building a scale model of Steve and the diamond pickaxe came next. I designed a mechanism that runs through Steve's arms to make him able to mine. Typically I'd use an axle, but this piece doesn't come in the right color, so I changed out this 1x4 brick for these instead, and used this bar and short pin to accomplish the same thing. It was time to build the machine's internal mechanism. The first thing I needed was a lift. Of course, gear racks were the first thought I had, but they would make the machine very tall. I tried this parallel lift arm mechanism next, but it was unstable and the cobblestone wouldn't travel in a straight line upwards, so I landed on a scissor lift. The scissor lift has a parallel table which ended up working very well. I eventually added some vertical guides so that the table wouldn't tip when the lift was extended. The only problem with a scissor lift is how hard it is to get the lift out of the collapsed position. I tried rubber bands here, and also here. Those helped, but added other effects I didn't want, like the cobblestone shooting off the top of the lift. Wow. So I decided to fix that a different way. I picked an NXT motor instead of an EV3 motor for ease of attaching to a base plate, and I got the lift motorized. I thought about moving the motor to a more convenient place using small bevel gears like this one, but the backlash caused the scissor lift not to function properly, so that idea was out. Next, I was about to add a conveyor, but as I was testing out an idea for it, I realized that a ramp could bring the cobblestone back to the lift after it was mined, which would eliminate the need for an extra motor. So I got started on building a frame for the ramp, and then I built the ramp itself to fit a cobblestone block. I tested it out and realized I would need a wall on each side of the lift to align the cobblestone, so I put these slopes on a plate and gave it a test. Then I built some supports for the alignment walls. These worked great for alignment, but they also were the key to the scissor lift problem because they raised the scissor lift out of its collapsed position. I put one on the other side too. These had to rotate out of the way so the scissor lift could actuate, but they had to turn in opposite directions. In one fell swoop, I built a wall, gear train, and motorized the mechanism. That was looking phenomenal. Next, I designed some smooth stone slabs. I started putting in the tops of grass blocks, the smooth stone slabs, and the water and lava. I used slabs because in Minecraft they contain the water and lava, but will allow us to see most of them still. I needed enough clearance for the cobblestone to appear near the water, lava, and piston, so I left a half stud gap on each side of the scissor lift table. The piston came next. The mechanism was a little complex, so I had to try a couple of designs, but eventually I got one that worked. I built dirt walls and mounted the piston frame onto them. I added a touch sensor so the piston won't over travel. I had to interface the piston rod with the motorized gear train somehow. This one could rotate. This one didn't fit the piston frame. This one didn't look accurate to the game. So finally, this is the one I settled on. It fits the frame, meshes with the driving gear, and looks accurate. It looks really good, and when the mechanism is covered, it will look just like the game. Next, I built a back wall so the cobblestone would fall onto the ramp correctly. I used these at first, but the cobblestone would catch on these pinholes and not fall. Next, I built some grass blocks here to vary the terrain and also for Steve to stand on while mining the cobblestone. He was placed here, but I wanted him to be rotated like this, so I added a green 1x1 round plate for him to stand on. He wasn't very stable yet, but I added a couple of supports later. I left part of the dirt blocks hollow to hide the special mechanism that will allow Steve to mine the cobblestone. This white bar connects to the arm with the pickaxe, so that when this thin tan lift arm moves, Steve swings his diamond pickaxe. To hide the mechanism some more, I ran the bar through an arch and used this modified brick to allow more room for the mechanism. Too bad I don't have one in brown. Next, I attach this linkage and rubber band so that when the axle is raised and lowered, the arm swings. I attached a motor and cam to get this axle moving quickly to simulate a fast mining motion. The machine is almost ready to run. The last thing to attach is the controller, so I added these lift arms, attached the EV3, and then used this wire management technique to wire the motors and other instrumentation. After writing a quick program, it was ready to run. My excitement was short-lived though, because after a quick test, I realized my initial plan of the piston holding the final cobblestone wasn't going to cut it. Even with fast enough movement and enough pressure, the cobblestone would still fall a few centimeters, which didn't look very good. So I needed one last thing. I'd already used 4 motors, which is the most one EV3 can typically control. So I picked this alignment motor to do more than one task. I added some gears here to get the correct direction of rotation, and then some U-joints and axles to get the motion to this side of the machine. I attempted to use this as the actuator for the slider, but it didn't have the necessary range, so I used this instead. This will be the proper effect. The final cobblestone will sit at the end until Steve mines it, and then the slider will allow it to fall. I just had to get the U-joints to connect to this slider somehow. A bonus effect is that the cobblestone will only be allowed to fall once the alignment mechanism is in place, since the same motor runs both of these mechanisms. Okay, now the mechanisms are ready to run. I just had to build this huge dirt wall and a bunch of flowers, grass, and plants to cover the machine and make it look nice. Turns out I needed more brown parts, so I added some black pillars to finish it off. I set the machine to run and watch the satisfying result. Check this out. The cobblestone appears out of nowhere at the water and lava, and then it disappears after it is mined, just like in Minecraft. Want to see it at 5 times speed? Now that's oddly satisfying. The machine is really consistent, so even when this happened one time, the machine just kept on running since the cobblestones are cubes. You can push this controller button to hear how many cobblestones Steve has mined, and presumably kept in a chest nearby.
Steve, you have mined 281 cobblestone, and score full stacks of 64, and a partial stack of 25.
When the mechanism is all covered up, it looks really cool and realistic. It looks amazing when the walls are removed too, and you can see all the mechanisms working. Share this on your social media so we can get this video to go viral. Watch one of these other awesome Minecraft builds too. Hit subscribe and tell me in the comments below which part of this build was your favorite. Thank you so much for watching.